אז שלום לכולם, אני אעשה את המצגת הזו באנגלית, אני חושבת שזה גם אימון טוב מבחינתי, וגם אני רואה שיש פה הרבה מאוד מאזינים שיכול מאוד להיות שחלקם לא יבינו אם זה לא יהיה באנגלית. So, pardon my English, it's not the best, but I will do my best in order for everyone to understand what I'm talking about, and I hope you would like it. So my name is Avíšag Shemesh. I'm a PhD candidate in the Faculty of Architecture and Town Planning Technion. This research is unique research. It talks about the connection between architecture and emotions. I have wonderful supervisors who are with us today. I'm not sure that Moshe Bar is here today, but Professor Yasha Grobman, Associate Professor Yasha Grobman, the Dean of the Faculty of the Architecture and Town Planning Faculty in the Technion, and Professor Jerry Leisman from the University of Haifa. Hi, hello. Hi, guys. I hope they can see you there in the... Do you want to say something, Yasha or Jerry?
No, I think the stage is all yours, and I'm looking forward to hear you speak about this wonderful research. So, thank you.
Okay, thank you. So I'm happy all of you guys are here today. And now, if you may wait for just a quick second, I will share the screen with you. And I will put the presentation on, and just hoping for your cue to tell me that you see everything correctly and that I can begin. Is that okay?
Yes.
Cool. Okay. So as I said, my name is Avíšag Shemesh. I'm an architect, a licensed architect here in Israel. My history in architecture, I worked in an office which we planned residential buildings, neighborhoods, and all kinds of wonderful things. And I did my first degree here in the Technion, first degree in architecture. And this is the PhD in Industrial Design lane. And the motivation for this research for me is basically to understand the connection between architecture and emotional response. Now, why is this important to me? It always bothered me during my first degree of studying architecture. You know, all the time teachers spoke to us about how spaces makes us feel more suffocated or more happy or more comfortable, and it always bothered me. Has anyone ever examined it? How do we know? So you know what? If you don't, I think I will unmute everyone. Is that okay? Yeah.
Yeah, mute everybody.
Yeah, so just a second. Danny gave me the option in the participants to unmute all. Ha! Okay, so now I can continue. Okay, so it always bothered... Did it work? I didn't mute you guys?
Can you mute all, not unmute?
Mute all.
You unmute.
Now you are all muted. Okay.
I see mute.
I did mute. Allow participants to unmute themselves? No, yes, of course. I want you to unmute yourself if you feel the urge to be unmuted, obviously. Okay. So, as I said, it always bothered me that I was wondering whether someone has ever examined that this type of an emotional response is really happening to us in a certain situation. So I wanted to examine it. But when we talk about architecture and emotions, we have to define, because architecture is, as you all know, a very big subject. And when we talk about architecture, we talk about the color of spaces, we talk about texture, about sound, about the form of spaces, a lot of different criterions involved in this wonderful world of architecture. It can be an outer environment, right, of the outside. We can say that maybe the blue is very dominant, maybe the shape is very dominant. Perhaps it's an inner environment, you know, like when we talk about design inside space, maybe the green of the space would be most dominant and would allow some certain of an experience, right? maybe it's not even the color, maybe it's just the light, maybe it's the shape that we notice when we are inside of a space that allow us to be immersed in it and feel some sort of a reaction towards it. So in this research, we talk about visual perception, right? We talk about how we respond when we see in our vision certain types of spaces. And the manipulated measurable environmental variables in this research are geometrical, okay? So we are focusing on the shape of space, of all the criterions you've just witnessed of the wonderful things architecture has to offer to us. We start in this research by examining shape. So when we talk about space, space refers to an architectural three-dimensional built environment, right? The human-made environment in this research that has recognizable boundaries because we want to know the setup that we're doing and examining it. And the space may be real and tangible, or it can be virtual and immersive. When we talk about emotional response, it's even more tricky than the definition of architecture, because emotional response is not an easy thing to recognize, as I have learned from this research, okay? So emotional reactions to an external stimulus activate the autonomic nervous system and involves an integrally generated cognition. Melillo and Leisman spoke about it widely. The emotional response creates bodily changes which are physiological in nature. So we're presuming that if someone experiences a certain emotion, we can recognize the physiological response to it. Maybe it will be in the brain waves. Maybe we can look over what he is focusing on. Maybe we can measure heart rate, galvanic skin response, right? How much he sweats when he notices a certain environment. So perhaps we can look for these phenomena of a human being phenomenon, and by this, understand the emotional response. So when we approach this type of research, we have to ask ourselves, what are the geometrical criterions of space involved in an emotional experience? Because it's not just, geometry. We have to define what geometry is. Can we quantify geometry of space? Can we measure an emotional response? Can we prove a manipulation in space geometry triggers an emotional response? We have to know that it actually the manipulation that provoked a type of a response or not, right? So how do we do this? We look way, way back, and the great philosophers from the ancient period spoke a lot about shapes, about emotional response towards shape. Plato talked about beauty. Beauty alone is both a form and a sensory experience. Aristo spoke about main forms of beauty that are order and symmetry. Vitruvius spoke about the structure of artwork. It ought to follow or imitate the structure and character of nature. So these great notions stayed with us, and the master builder, the great architects, we can think about Frank Lloyd Wright, we can think about Peter Eisenman. Great architects used their experience, their massive experience and their knowledge to plan and design spaces which affect us positively. How did they do it? They were like the big magicians of the times. And they had a rule of thumbs, perhaps. They knew stuff from their experience that we perhaps don't know. And even wrote a book about it. Christopher Alexander wrote a book about the pattern language. Presumably, if you would follow these rules, right, the pattern, then you could perhaps design better spaces for people. But if we want to speak about a more empirical, scientific point of view and understand more about these processes that I spoke to you about, the emotional response and physiological response and the cognitive response towards these spaces, then we have to look even further for more scientific fields. So this research is very multidisciplinary. It's created a lot of challenges, but this is, I think, why it can be very interesting, I hope, for you guys. So we spoke about our mind, right? So we use science from neuroscience. We use cognitive psychology, environmental psychology, psychiatry even, psychophysiology. We look about different types of fields, of course, architecture and philosophy, to try and get the full image as much as we can. So if we talk about symmetry, we mentioned symmetry, then we know symmetry is everywhere, right? We have symmetry in nature. We have the fight or flight. We have butterflies and animals and faces. And we know that there's an emotional response. We presume that we have an emotional response towards symmetry. And it was actually, it is still a big subject in neuroscience. And also curvature, right? If whether a shape, a certain shape, it doesn't matter if it's an object that we know or it can be an abstract object, a shape, whether it's curved, whether it's sharp, we know that these differences can affect us. And it was found that there is a tendency to prefer curvy shapes for non-experienced participants and users. Okay, so I like to bring this example. When I ask people, I ask them which type of a table would you prefer? Would you prefer the round table? Would you prefer the sharp table? And also we can talk about buildings. If we look at buildings as they are like statues from the outside, would you prefer the curved, the achadid building, or would you prefer the sharp building? Okay, so we know, we suspect, if to be exact, that there is a difference between users that are experienced in the design field and people who are not in their perception towards these objects or spaces, if you want. But spaces, when we talk about space, if we look from the inside, there is a research that examined this difference, and they used fMRI, okay? It's in order to detect blood flow in the brain and to see where there is more response towards this type of space. But if you look at these spaces, it's not just rectangular and curvature that we are looking. We see a lot of colors, right? So it's a bit tricky to understand what is the criterion involved. Even if we eliminate color and we bring pictures, these are only pictures. We don't really experience space. We can look at it, we can say what we think of it, and what we say perhaps is not equal to how we react. We will talk about it also. And research in 2014, Dias and Eloy et al., they have started to use the VR, the virtual reality, in order to examine it. What's so pretty about the VR is that we can synthesis from the word build and create a certain type of an environment setup that allow us to isolate variables and examine how we react. So they use GSR, and they brought really extreme situations like a bridge, a pathway, and they asked people how happy and pleasant, and how they feel sad or these type of sort of things. And this is a start of examining how people react towards this type of situations, perhaps architectural situations, if you may say. And the research from 2017, they examined through the use of VR architecture style, right? They put all kinds of different styles of architecture inner spaces, and they allowed participants to walk through space while using an EEG device, which measures brainwaves, different types of brainwaves in our brain, in order to investigate whether there was a response to this type of space or another. So this is, we take a bit of everything, I think, and we witness several types of things that we have to gap, you know, 7 types of gaps in literature that we have to deal with. So first, the idea of an emotional response is very tricky. It doesn't really happen in just one place. We can't just really look at a brain and say, okay, we know how people respond. The autonomic system of our body is complex, and it has a lot of different physiological responses that we can look at, as we mentioned before. It can be sweat, it can be eye tracking that we use, it can be a lot of different things. And we also know that asking is not enough, right? Because what you say that you feel is not, maybe it's not identical to how you really react towards a certain space, right? We have the cognition that affects this type of aesthetic judgment that happens later on in the process. So there's this, and there's also the process of experiencing space, right? It's not just like looking at one space or another. You have to be immersed inside of a space in order to feel some sort of a reaction, and perhaps we can measure it. So we want to prove a connection between properties of space and human emotions exist, and we want to perform an empiric measurement of emotional effect generated by changes in the geometry of space. So we conduct a wide multidisciplinary literature review, and we combine qualitative and quantitative research. And we also use VE, obviously, and we use a combination of several systems which record the limbic system involvement in the process of emotional response. We use parametric computational design. Why do we do this? We want to quantify the geometry of space. We want to manipulate shapes. This is an experimental research which collects data and examines aims, hypotheses, and methods through the use of several statistical analysis methods. We also have a cooperation with the electrical engineering department in the Technion, Professor Ronen Talmon, which allows us to use a very sophisticated algorithms in order to understand how these responses are happening, and we will talk about it later. Now I want to show you the process, okay? This is a bit heavy, so I will try to shorten up. So at first we start with the literature. We started with the literature review, and we did a preliminary experiment. Why was that preliminary experiment important? It was important in order to investigate definitions: pleasant, not pleasant, comfortable, not comfortable. How does these things, how participants experience those types of definitions? This was based on questionnaires, right? Then we had additional literature review and went to the pilot experiment. The pilot experiment was just adding a physiological sensor, right? We used EEG, and then we wanted to see how people react. And then we noticed that they have to sit down, right? They can't move around space because they use an EEG. And then on further and further, and we went to a main experiment. In the main experiment, we added even more sensors. We added even more criterions of geometry according to the literature review. And then we collected conclusions and used all kinds of cooperations and used algorithms and et cetera, et cetera. So this was the big frame of the research that I wanted to explain to you. So as I said, we started with a basic, I can say maybe spaces. We have a square, a sphere, and we have a sharp asymmetrical space, and we have a curved asymmetrical space, and we gave participants, both designers and non-designers, to experience these type of spaces in the Technion computer Viz lab. They stood near in front of a big screen. They had a joystick, and they could look freely. And then later they had to fulfill a questionnaire regarding their experience. And as I said, we used both designers and non-designers, because research from literature shows that there is a difference between how architects and designers experience a space or design and art more frequently. Space is less common in the literature to witness than those of engineers, and we have lots of engineers in the Technion, so it was easy to recruit these type of participants. And then we saw an interesting thing. We saw that there was a statistical difference in the criterion of when we asked them how interesting the space was to, as they thought. And they claimed that the sharp space, the asymmetrical sharp space, was less interesting towards them than that of the curved asymmetrical space. So this was a significant difference. So designers show a tendency to prefer asymmetrical sharp space. the designers, while the non-designers, as I said earlier, show a tendency to prefer the asymmetrical curvy space. This was based on a liking score. Significant difference between reported feelings of interest among designers and non-designers. And then also was a gap. What was that gap? The gap was between the first evaluation, the liking score, and then a later response, which was even stronger when they had to describe their experience, right? So this also helps us to understand that the process of experiencing space is changing as it's happening according to the time. So to sum it up, a review from 2019 mentioned this research that we are describing is one of only 7 studies out of 237 records that actually start to recognize the problem and start to try and investigate it. And it claims that there should be a more methodological approach of doing that. And then we obviously want to do that as well. So we start with a pilot experiment, and we use the diffusion map algorithm, and we color the brain waves accordingly. Participants look at space, and then we record the brain waves, and then we put the diffusion map algorithm, and then we see that according to the brain waves, you can see different colors, and every color relates to a different space. So you can see that they recognize differently each and every space. We don't know how they feel towards the space, but there's a pattern that describes each and every space according to curvature and according to symmetrical and non-symmetrical. So if we take it even further, we can look at additional indications such as eye tracking. Eye tracking was used in literature mostly in art, and we have researchers that follow eye fixations. Where do we look at the picture? How long do we fixate? And what is it that interests us, right? So you can see with the Pitt-Mondrian, you can see that that you can see the blue dot. So people fixate longer when something catches their eye, right? And it can be due to the horizontal lines more than to the non-horizontal, which is maybe less pleasant to the eye, right? Do we have that in space? And we can add a dimension of protrusion, okay? So just to be quick and to explain to you what do I mean by protrusion? When you look at the picture, at first you're not really sure what you're seeing, and then after a few seconds you can decide whether you see mountains, whether you see cats. So this is the principle of binding, and also happens when you witness a certain type of a shape, and then you feel, oh, now I understand what I see. So you can manipulate this, and you can use it maybe perhaps in space, right? So this also has a lot to do with the peak shift principle, but I won't describe the peak shift principle at the moment because I don't think we have enough time to go over it. And we also used the dimension of proportion, and we use scale because we have we can think about those criterions as perhaps criterions that affect us. We can see that in industrial design, how proportion of shape can bring us to an emotional response. This is more nice, this is less nice. But in space, not a lot of people examined it. There was, I think, 1 or 2 researchers that examined it, and they used that notion of VR in order to examine how people react for claustrophobia, right? So we know that. We know that there is literature involved in that, but very, very seldom it was investigated. So this graph is like a combination of several different types of things describing how we use the setup. We have the participant sitting and wearing the goggles, the VR goggles. We have the computer. We have the wireless EEG headset on his head. He also has attached to his hand GSR device, and he has the eye tracking, the pupil labs eye tracking attached inside the VR. And he can he can witness space, and then we can measure how he reacts towards different types of manipulations. This graph is important because this is our assumption. Our assumption is that we can measure an emotional response. How do we do that? There is low arousal and there is high arousal, and we hope that when we take all consideration, how long did he stay in that space? How did he scale that space? Because we also asked them, how much do you like the space? So if we take all of these, combining physiological measurements, perhaps we can say this was a high arousal or a low arousal of a response, and whether it was positive or negative, right? So this is like our main assumption of the research. And we used Grasshopper, obviously plugin in Rhino, that allowed us to manipulate the shapes in a very measurable way, because we know how much curvy the shape went, and we know how much protruded it went because we actually measured it, and we had an algorithm that we can control it. And then we know if we compare it to the emotional physiological reaction, then we can see the differences, right? So we designed 27 shapes, and they were different with the curvature, as we spoke. And they also with the protrusion. Protrusion means that how much is the facet, the point on a facet goes outside further and further, how much it bumps out, right? Because when it doesn't, it can be symmetrical. It can be just a simple box. But when you start to protrude it, and then the facet has more and more and more extreme edges, then perhaps you can witness a response that is accordingly. Also, we examined width and height, right? How high we got the ceiling be, and how narrow or wide we got the walls to be when a person feel immersed in that space. So this is what happens. There's a participant, and he sits, and he has all the devices attached. And then we have the Unity, and the Unity is a real-time engine that allowed us to, how do you say the spaces kept changing without us knowing the order. I forgot the word for that. And this is what happens. Okay, so the person is inside space. He has the eye tracking. He can focus. We know what he focused on because we have the time frame, right? We know exactly what he looked at in every single second. And we have the physiological sensing attached. So we can see in the screen his brain waves, and we can see how much he sweats, and we can record it, and then later we can export it and analyze it. There you can see we also asked him right after the space that he experienced, how did you feel? Or how much did you like the space? And we also asked them uses. I won't go into that, but uses can also affect how you feel, whether it's positive or negative towards the space. Okay. This is an example of curvature versus non-curvature. Right, it's a transformation. You have like 5 spaces from most curved to non-curved in an asymmetrical space, and a person experiencing them. So what happens basically at the, let's see the time just in order for me to know. Yeah, have to sum up a little bit faster. So what we can see is that we have a participant, right? He has 27 different spaces. You have all the types of measurements that we measured fixation duration and peak of GSR, pupil diameter, and we examined sensors, 5 sensors of the emotive insight that he wore on top of his head. And then we examined the active scene, the part in which he actually experienced space, and we used a wonderful, wonderful collaboration with a statistic department, Naama Wolf and Paul Fagin, Dr. Naama Wolf and Professor Paul Fagin from the statistical department in the Technion, to also do their analysis, because this is tons of data. This is really, really a lot of data. And what is most special about this data is that every type of measurement is taken in a different different way. We have milliseconds, and we have seconds, and we have per minute if we talk about GSR peaks, right? So we have to put them all on top on one scale. It's not an easy thing to do. So, and then later, we started to investigate and understand what happened there. So if we talk about how much they stayed in a space, right? We put them all spaces. We took 27 spaces and examined how long did they stay in a different type of space. And we also use different types of statistics, univariate statistic and multivariate statistics, in order to understand whether there was a difference. And also we examined the pupil dilation, right? And not just pupil dilation and maximal pupil dilation, in order to understand whether the certain type of a criterion made their pupils dilate more, and what was the maximal pupil dilation, right? Also fixation, the amount of fixation, how much fixations could we count? And fixation duration, how long did they focus on a certain space? So we took those types of variables, also GSR peaks, right? We can see that the curvature had a higher maximal GSR amplitude than those of not. And we also investigated the relations between the sensors, right? Because perhaps it's not just GSR that allowed us to understand a certain difference, a statistical difference, right? So we can see, for instance, that the curvature had the least of the prediction of the multivariate statistic of I think it was the pupil dilation, right? Yeah, the pupil max, and vice versa. In the sharp, it was the highest. So we also have to understand which type of measurement is relevant to our understanding of the different phenomena. Same goes to size when we examined it, and to proportion. We can see that narrow proportion had the longest fixation duration, and it was the most evident out of all the sensors examined. And also, when we use the diffusion map algorithm, we only witnessed this type of identification in the pupil dilation. So how do we deal with that? We take all of those different things that we witness, and then we try to understand what goes on. We compare different statistics. We compare the different diffusion map algorithm and the classic statistic and the duration and the liking score and the uses and everything. And then we start to sum up. It's a lot of summing up to do. So I will tell you a little bit, and I will try to do it fast because we have to sum up. Unlike results of liking evaluation, we identify an emotional response to sharp spaces. Now I want to unmute you guys, because this is like, I hope I'm not talking to myself. So now you're unmuted. So now you can tell me, wait, I don't understand. Okay. Great, now I can hear you, and then you can stop me if it's important. So unlike the result of a liking evaluation, remember that we talked about curvature, then we witnessed the emotional response towards sharp spaces, okay? And also we saw the criterion of protrusion is really impactful. So the stronger the protrusion went, the stronger the emotional response. And the most interesting, a very interesting thing that we witnessed was the middle, the space that in the middle, right? It is half curvatured, half non-curvatured. It is highly protruded, and it has a very, very high evaluation of all sensors, physiological sensors, liking evaluation, uses evaluation, and length of stay. All of these criterion showed a positive emotional response of being in that type of a certain space. We saw a very strong response, emotional response, negative emotional response when you are inside of a narrow space compared to a wide space. And this response was even stronger than early researchers that are dealing a lot with the height, the ceiling height. So not many researchers examined the width, but the width is actually even more powerful than those of the height. It can be due to field of vision, right? And also, we look about we suspect that square and a sphere has a different we react differently towards it. We're still not sure whether it's because of the symmetry or because these spaces are familiar to us. Earlier research talks about symmetry, but we still have a lot of investigation to do in order to understand that it truly relates to symmetry and not to the fact that it is familiar to us. And we also learn about the process, emotions and compared to feelings. We see that there was no correlation between the emotional, the physiological responses and the liking score. There was none. So at first we were like disappointed, how come? But then we understand these are different types of processes. How we react is not exactly identical to what we say and what we think afterwards. And also a very interesting thing was to understand the difference, the long spoken about difference between designers and non-designers, right? So we see that actually designers, sorry, now I will mute you again. Sorry for that, guys. Mute all. So we see that the physiological responses of non-designers are actually higher of those of designers. Designers actually do react emotionally different than those of non-designers. So this was very interesting, and it has a lot of ideas worth pursuing when we design, to whom we design to. We don't design the same when we design toward designers or non-designers, right? We have to think about it as designers by ourselves. So this is very interesting. And also about the perception process, we see that after 2 seconds, there starts to be a differentiation. So this process of observing space happens very quickly. After 1.5 seconds, 2 seconds, then we already have a response. And then we can measure, you can see all the responses one on top of the other. We can add the statistical and understand how these physiological responses in a certain second relate to one another. So this would add additional statistical, this is like for future research, we can use all the data in order to understand the different peaks. What happens, whether in a specific second, there's a peak when we look at a certain specific point, when we look at heat maps, right, of where we look inside that space. Was that a corner? Was that a stain? Was that a shadow? What was it exactly during a specific second, and what happened to our physiological response, right? So this goes on for further research and further analysis. So a connection between properties of space and human emotion is evident. Both positive and negative emotions are recognized. Several sensors contribute better than others. Further research is needed to understand whether a certain device relates to a specific emotion. We're not really sure about that. We believe that it's a combination of several that will give us the best evidence. And we've proven that quantification can be performed both geometrically and emotionally. The new knowledge that has accumulated in both of the influence of geometry in reading emotions and understanding the space perception process. So we talk about, here I present you additional stuff needed to do in this presentation, and I will continue because we have to sum up. And I just want to tell you that I think this type of research and other research following and parallel to this research perhaps is very important, because we keep investigating climate, we keep investigating structure and cost, and we have a lot of type of criteria. We can measure how good a building is and how positive and how successful it may be, but there is a human criteria. It is hard to quantify, but it needs understanding. It needs understanding because it can be understood. And I believe personally that whatever could be understandable should be. And then we can think about consequences, and then we can think about what we need to do with that understanding, because it is a very potentially very strong and impactful knowledge, right? But it's in our reach. We can continue and understand that, and we can contribute to custom-made user-oriented design, and to better prediction and evaluation of design, and to maybe perhaps hopefully spaces of healing could be our point of you know, what we want, and not just spaces to make you feel bad, right? Hopefully not that would be the solution. And encourage evidence-based design. This is what actually is the biggest thing in this research. So thank you for hearing. There was a lot of information. My professors know every day that passes, I try to sum and understand it. It's like a tons of information, but I hope you get a picture. And I really want to say thank you to my dear professors, and I mentioned the statistical department and Professor Talmon, and I also want to thank you, Ofer Karp and Idana Mir and Ori Katz and Itzik Gold and Tom Palny and Adi Belsen and Dor Schreier and Asaf Schwartz for his contribution, and the faculty of architecture and town planning Technion. And I really want to hear what you think. I study all the time, and I need to assign the dissertation soon, so hopefully whatever you tell me, I will learn from it. And now I will put you back. I really wanted to hear you, but there was like this background noise, so now it's a better time. Hi guys, let's see what time it is. Okay. On time, more or less, right? Danny. Are you there, Danny? Danny!
I am here. Everything okay. Questions?
Why did you do that? What did you think? What on God earth did you think? No?
Wonderful presentation. I enjoyed it, even though during work I took an hour off and I decided I want to see the results.
Tom, the master builder of the mind.
Did I unmute myself or what? What's going on here?
I let people talk.
Okay.
Talk. Whoever wants to talk, talk away. No, but really, if you have like something that is like bothering you or annoys you, or why did you do that? Or how did you do that? Or I don't know, just like cool, whatever, I don't care. And not, it's also okay.
Avishag, I have a question. You hear me?
Yes, Adas.
Okay. First, thank you for this wonderful presentation. And I wonder what's the next steps as our physical environments as well as virtual environments become highly complicated with and equipped with complex shapes rather than צורות גנריות.
כן. כן.
אפשר לעבור לעברית אולי. לא.
No, I will answer it.
Yeah, answer in English, please. Sorry.
No, it's okay. So in English, just to say, what would be maybe the continuation? Would it be like to investigate physical surroundings or both virtual surrounding physical? What would it be? And yes, I mean, the purpose eventually is also to investigate physical environments. The beauty in the virtual environment is that it allows us to isolate variables. So potentially, if I have enough time to live, and other researchers obviously, potentially if we investigate different criterions, it can be color, it can be it can be sound, and we can do that for different type of criterions, and we add more and more knowledge to it. Then we can have a bigger picture and bigger understanding. And then when we design, we have like the software, right? Like we have the grasshopper and the rhino, and we have those little blueprints that help us to say how much we like that form or the other form. But imagine if that you can also put inside information about your age, your gender, and all types of different variables, your culture, your whatever, and then perhaps participate, perhaps evaluate whether this shape would be pleasant or not, or whether this shape with color, with sound, with whatnot, with. So it's adding more and more knowledge to this empirical or this evidence-based design. And I think if we do it correct, if we do it with responsibilities, and it would help us to create better environments, yes. And it would be cool to investigate real environments, but it needs to be taken care of, you know, one step at a time, I believe, because there's a lot of information in the physical environment.
Thank you.
You have questions from the chat, actually, if you could look at it. Like Uri is asking, can the difference between designers and non-designers be explained by only the effect of novelty?
Oh, wow, yes, chat, okay. Can the difference between designers and non-designers be explained by the only effect, by only the effect of novelty? Can the difference between designers and non-designers be explained? I'm not sure I understood only the effect of novelty, but the difference between designers and non-designers, we don't know, if I understand this question. Because it's like the chicken or the egg. Do designers see things different because they were born, you know, as looking at things the other ways, or they during their experience accumulated knowledge, accumulated perception, and now they see their things differently, and now they respond differently? We're not sure.
Avishag, how do you define novelty?
I think if I understood the question, I think he meant, or she meant, familiarity.
Great. So if you repeat a stimulus multiple times, after X number of times, it's no longer novel. Would you still get the same liking and unliking response?
Yes, and but I think either way, I think it's interesting to know that if we design to designers, then we should take that into consideration, whether it's from novelty or familiarity, because maybe the expectations are different in advance, and we have, you know, we saw in this research that designers, they actually liked relatively, they liked the high ceiling. And non-designers, I think, hated it, disliked it. So they are used to extreme shapes. So we have to take that into consideration with the design. Who is going to be in that design? When we design large spaces, right? We see people stayed longer in large spaces. So it is important for us to understand that when we design large buildings, what is the use? Would they be fascinated in it? Would they be bored in it? Would it be designers inside, non-designers, or other types of children, elderly? We can go on further and further and investigate different type of populations also. יש עוד. אוקיי. משמעותי להבין איך הסביבה הבנויה והמרחב הציבורי עד לכניסה לבניין משפיעים, בהחלט, ויוצרים מצב רגשי ראשוני ופתיחות לחוויית המרחב הבנוי ועיצובו. האוריינטציה של התנועה בבניין והצפיפות בו משתנים, המשולבים ומעוכבים עם התגובה למבנה ולחלל או ניתנים להפרדה. זה בהחלט, this is a very important thing. The process of space perception is what Naomi describing here. The process is important, and what we come before and what we see later is important. And if we come pissed and if we come unpissed or happy or not unhappy, it's important. And when we enter from one passage or doorway to another, we still have the image of the space before, and then we continue to the next. and there's a difference, right? So in this research, we had to eliminate it. We gave participants the same environment in advance in order for them to feel or have the similar emotional response. And then we started same, identical for everyone, just in order to have a blank page. But of course, in the real life, you come from one space to another, from one environment to another, and it's dirtier, if you may say. So yes, it affects, but I think that in order for us to investigate it, we have to take that into consideration, absolutely. Most of the literature actually talks about the difference between one space to another, less of this certain specific process of a specific evaluation of space. האם התגובה למבנה מורכב היא אקסטרפולציה של תגובה לחלל יחיד? מעניין. Maybe novelty to design is different from novelty to the frequent exposure to structures. Yes, so it's like a tree. There is like, I called it inside the dissertation, I called it, I don't know whether you like these definitions, my professors, but I called it inner landscapes. Inner landscapes. I mean, it's like a scale. You have a large building, and you can look inside a building. You can still look inside a room, and then you look inside a room, and then you look inside. So this is why the heat maps that we used. I can't wait for them to be analyzed even further, because inside a specific space, you can actually maybe look for the inner landmarks or the areas of interest, right? So I think when you talk about extrapolation, I think this is a really important subject for further research, and we have the data, so it can be in some way can be investigated, if I understand correctly. Marina Epstein, thanks, very interesting. Unfortunately, I have to go. Well, I was so happy that you joined, and that's it, Johnny. I can talk, until tomorrow with you guys all day. That's what I do anyways, but I don't want you to